function fx is equal to e to the power x over 3 plus e to the power x. We will try to plot this one. So first we will see what are the x and y intercepts of the function. So when x is equal to 0, we will see what's the value of y. So if x is equal to 0 for the function y, basically this is our function. So when x is equal to 0, y becomes e to the power 0 is 1 plus 3, that's 1/4. That means the function cuts the y-axis at 0 and 4. So 1/4. So that's the y-intercept of the function. So now I will try to find what's the x-intercept. So when y is equal to 0, 0 here e to the power x, 3 plus e to the power x, that leaves us e to the power x is equal to 0, which has no finite solution. When x is equal to minus infinity, only then it cuts the x-axis. That means this is an asymptote. Basically the function reaches the x-axis when x is equal to minus infinity. So that's there. Now we will see if there are any stationary points. That means if there is any maxima or minima in the function. So at a stationary point, the first derivative will become 0. So the first derivative of the function is, if we do first derivative, that will be e to the power x plus 3 whole square, then e to the power x plus 3, that remains like that. The numerator will be differentiated, which will give us e to the power x, then negative minus e to the power x, and differentiation of the denominator, that is ex, e to the power x plus 3. The differentiation of that also gives us e to the power x, because differentiation of 3 is 0. So this one becomes here e to the power x plus 3 whole square, and e to the power 2x plus 3 e to the power x minus e to the power 2x. So that is again 3 e to the power x, and these two getting cancelled, so that one. So this is the first derivative. At stationary point, this one will be 0. So 3 e to the power x, e to the power x plus 3 whole square is equal to 0, and we can see that means 3 e to the power x is 0. So we can see that there is no final solution of x here. That gives us that there is no stationary points in the function. So it doesn't have any maxima or minima, the function. So that's there. Now we will see if there is a point of inflection. That means when f prime double prime x is 0. So we will find the second derivative of the function. That will be e to the power x plus 3. That was square, but then squared again. So will be to the power 4, and then e to the power x plus 3 whole square. That one stays there, and differentiation. So basically I'm trying to differentiate this one. So that will be 3 e to the power x here, and then minus 3 e to the power x. This one will become 2 e to the power x plus 3, and then differentiation of just that part will be e to the power x. So that will be equal to 0 at any point of inflection. So this one is cancelled, denominator. I will not write the second derivative. I will just write the equal to 0 equation. So basically this is now becoming, or maybe I will just leave like that. So yeah, plus 3 whole square here, and 3 to the power x, and then this is 6 e to the power 2x, I guess, and then e to the power x plus 3, and in the denominator this is plus 3 whole to the power 4 equals to 0 at point of inflection. So what I see here, I can take this as common here, e to the power x plus 3, and then this one becomes 3 e to the power x, e to the power x plus 3, and minus here is 6 e to the power 2x. That's there, and here it's e to the power x plus 3 whole 4, and that will be equal to 0. So this now can be written as e to the power x plus 3 whole cube here. This one divided by, so basically from these two I can write that. So this is 3 e to the power 2x multiplying this one plus 9 e to the power x minus 6 e to the power 2x. That's equals to 0. And then here this one can be written, this is 9 e to the power x minus 3 e to the power 2x equals to 0, and here it's e to the power x plus 3 whole cube. Finally, from that I can write 3 e to the power x, if I take that out from this one, so that will be 3 minus e to the power x, and in the denominator will be like that, equals to 0. So now we have something, we can try to solve this one for x. So this becomes either 3 to the power x is equal to 0, which doesn't have any finite solution of x, so this cannot be 0, or 3 minus e to the power x is equal to 0, or e to the power x is equal to 3, so x is equal to ln 3. So that's a solution now. So we have a value of x for, and so there is a stationary point, and when x is equal to ln 3, y is equal to, y is e to the power x plus e to the power x plus 3, so that will be, x is equal to ln 3 e to the power x is 3 plus 3 here, so that's half. So the stationary point now becomes ln 3 and half. So ln 3 is almost 1.098, something like that, so it's a positive value, of course. So that's the point of inflection, which is somewhere there, half, and then this one, and this is where it cuts the x-axis, and this is where the curvature changes basically. Now we will see what happens when x is equal to infinity, or negative infinity and infinity basically. So when this one, what happens to the function? So limit x tends to infinity. So we are trying to find out if there are any asymptotes. Asymptotes is when the function becomes parallel to a line, or basically it reaches that line when the value goes infinite, something like that. So e to the power x, e to the power x plus 3, what's the value of y we are trying to find out when x is equal to, x tends to infinity basically. So this one becomes limit x tends to, sorry, minus infinity here, so that would be, if I divide this one by e to the power x, it will be 1 plus 3 e to the power x. So when x is equal to infinity, this one becomes 0, and then this is 1. So y is equal to 1 when x is negative infinity. So it reaches, sorry, this is positive infinity when this one, so basically I'm doing the positive infinity first. So e to the power 1 over e to the power infinity is 0. So if we say this line is y is equal to 1, the function reaches this one here, becomes parallel to this one at when x is equal to infinity. So this is x, this is y, and then when x tends to negative infinity, limit x tends to negative infinity, this one was positive here, so y is equal to this one, e to the power x, e to the power x plus 3. So when this one is already e to the power minus infinity, e to the power minus infinity plus 3, so basically this numerator becomes 0, and this is 0 plus 3, so this is 0. So when x is negative infinity, y is 0. So basically it reaches, this is y is equal to 0 line, the x-axis. So the function becomes something like, so I will re-identify the points here. So maybe this is 0 and 1/4, and let's call this one ln 3.5, which is the point of inflection. So it goes something like that. Here it changes the curvature and it becomes something like that and reaches the y is equal to 1 line at positive plus infinity. So this is minus infinity, where so basically it becomes asymptote with x is equal to 0, sorry, y is equal to 0 and y is equal to 1. With these two lines, this is the function becomes asymptote. So that's what the function, that's how the function will look like, the curve will look like. Actually, y is equal to 1 and y is equal to 0, these two lines become asymptote for the function. That's how the asymptotes are actually the straight lines. So yeah, that's the correct expression.